So, we are talking about a product called Kubernetes. This is how we pronounce it. Sometimes I call it, uh, sometimes I call it Kubernetes, but it's the right pronunciation for it is Kubernetes. Um, it is. Sometimes we call it K8s, by the way, so to save ourselves some time and pronunciation lesson, so we can say K8s. K8s, why we call it K8s? When you search on it, you will find that this is the number of letters that coming after the K here. So that's why they call it K8s, just in case you're wondering why we have this K8s. And I guess you saw in your labs in the previous days that we have three Ubuntu servers. We call them K8s 1, 2, 3. These are actually going to work as a Kubernetes servers. What is this application and why we need it? We are saying that application is not a big mono anymore. We are living in microservice architecture. We are taking our application and chunking them into small pieces, and these pieces can be represented as a container. So you remember when I said you have one application divided to 5, 6 functionality. Each functionality can be represented as a container. This is how microservice life is happening nowadays. And the idea is simply we have a lot of applications, and these applications made of a set of containers. Sometimes we need to install this application in this environment, then we will add another application. Or sometimes we will need to have high availability failover capabilities for these small containers. And I explained that before, and I said that we can have one container, another container, and we can have a load balancing between them. But how to automate this? How to make this automatically? In the end, this is a DevOps course, and we are talking about automation as one of the 5 principles for DevOps. So I need something or a tool that can automatically assign the containers to available servers and can scale the critical components. And when we say critical component here, it means the containers itself. And this scaling should be happening also automatically. This is where K8s will come to help us. It is working as orchestrator for our microservice applications. Kubernetes is open source orchestration tool, and it will help us for automating the deployment and the scaling and failover and management for our containerized application. And when I say containerized application, that means this is a microservice application. What is the container software that K8 is supporting? It's supporting Docker, supporting Linux container, supporting RKT. It can support many softwares that are in the market that can create containers nowadays. But we know that Docker is number one, and this is the one that we normally use to create containers. But anyway, if you don't use the Docker, you are using Linux container, K8 is supporting it, and no issues with that. Normally, K8s will be running behind in the back end. No one will see it. The user will use the application, and they will never know that this application is divided to a set of containers, and these containers is actually existing maybe in multiple hosts. So I can have two container here, one container here, 3 containers here. And all these containers is representing one application for me as a user. I will never see what's happening in the background, but in the background, thanks for K8s that can tell these machines, create these containers and make sure it is running, and also can provide me failover and scaling. Scaling simply means that maybe I have one container here in my application that's running as logging or giving me a functionality but I need to scale it now, and I need to have a bigger size from this container, so I can create another container that doing the same thing that this guy is doing. Also, in the same time, maybe I have one container here that going to lose the connectivity or maybe going down. I don't have issue because maybe I have another container here that doing the same thing that this guy is doing. And once this guy go down, I have that another container with the same component will come up and do the job quickly. So I have a concept of failover. Again, thanks for K8s that can do all these things for us. Here I'm explaining again the functionalities that your application could be made of different functionalities, and each functionality will have its own container for sure. So application like this will be created of at least 6 containers. Containers can talk to each other, by the way, using REST API. Now, we need to understand Kubernetes architecture before we start talking about the storage and networking and security capabilities inside this application. To explain this, I will say that K8s working in a cluster environment. In K8s, we will have one machine. We will call it master node. And I will have one or multiple machines. We call it working node. Now, this master node, you will find it with different names. We call it different names. In the end, it is the same thing. We can call it master node. We can call it API server. We can call it control plane node. Whatever what I'm calling it, in the end, I'm talking about the same device here. This master node is controlling the working nodes and managing the working nodes. The working nodes machines will have the container inside it. And this master node will manage these working nodes. Can I have more than one master node? Because having one master node will be a single point of failure. Yes, you can have 3, 5, 7, or 9 master nodes. It is up to you. And we can say that their cluster, we can have about 500 nodes, by the way. If you told me how many working nodes I can have, up to 500 nodes, something like that. In the official material, the official documentation from K8s, it will say 5,000, but in the production environment, with the experience of the users, they are saying that it is 500 nodes. There is a good website here. You can give it a look. It is it's comparing between K8s and Docker. Actually, comparing between Docker and Swarm and Q8s, but inside it, I cannot agree fully with this title, Kubernetes, because this is the container creator application. This is orchestrator for them. But it's showing you in the end few good tables. Where is it? In the end of the page, you will find differences between running Docker without orchestrator and running it with orchestrator, how many containers you can have, how many nodes, logging and monitoring, the size, how no more than, you can see 5,000 nodes. As I say, in production environment, you'll find that 500 is good. And they have some stuff here that you can read it. Anyway, so we have a master node or API server. You can call it API server or master node or even control plane node. And we have the working node. So the idea here that I will talk with the master node and I will tell the master node I have an application. This application made of 6 containers. I would like to see it running in this cluster. Master node will have a small component, we call it scheduler. The scheduler will try to find how many working nodes we have. We have 3 machines, 3 servers. Okay, which one will have a space to host these containers? Maybe the second one and the third one. And I will start creating the containers that representing your application on them. So this is the benefit of master node. It's controlling everything. Now, what is the operating system and the main application that I will need to have it in this server and in that server, master node and working node? For master node, the machine could be Linux or Windows operating system. I need DNS capabilities for sure, because sometimes your application itself will be represented with a name, and I need Docker to be installed. In the working node, I need the Linux machine, not Windows machine. The machine's that going to be, it makes sense because I need Docker here, and also I will install Docker in the working node. So working node will be Linux machine, and I need Docker installed because I have containers here. Now, maybe if there is a question will come in your mind right now, why I would need Docker in the master node, since it is not going to run the containers. Running the containers is the job of working, so why I will need master node to run Docker here? Frankly speaking, K8 is going to, K8 is example for microservice applications. K8 itself is a microservice application. What does this mean? It means that in the next few slides, I will talk about the components inside master node. And whatever I have 4 or 5 or 6 components inside the master node, each component is running in its own container. So the K8 itself is acting as a microservice application. That's why we need Docker here. So let's start talking about working node, then I will go to the master node. In working node, you said that you will have containers. Okay, here is container 1, container 2, container 3. But what is this books that I have it that contain these containers? This box here is called pod. It is like a cover or envelope for your containers. Now, each pod can have 1 or more containers. Normally, take care from this part. Normally, we are saying that when you create a pod, you will have 1 container inside it. So, and some people using K8s will deal with pod like this is the terminology that K8s is using to define container. So instead of saying I would like to create a container, I will say I would like to create a pod. This is true, but not completely, because you can have more than 1 container in your pod, but with some conditions. First, you can, when you have a container here, this is container 1. Let's assume that this is a HTTP container. And this HTTP container will need some logging capability. I can make this a logging capability for the HTTP. So container 2 is serving container 1. And container 2 with 1 is a part of the same application. You cannot say, I will have container 2, which is providing me logging functionality for another application that actually exists in the third pod here. No, they need to be related to each other. Second, or another condition that you need, or another important thing that you need to put in your mind. it will make no sense to say container 3 here will be also look for why? Because I would like to have load balancing or failover capability. No, because when you think about high availability, when you think about failover, you think about it from the perspective of bots, not containers inside the bots. So having this guy here look will have no meaning, because if this bot goes down, I'm losing the 3 containers. So I don't care about these 2 containers that having logs inside. Each bot has its own name, IP address, and MAC address. But normally this IP address will be used for internal communication inside the cluster itself. What is the maximum bots that we can have? Here in this example, we have 3 bots, and one has 3 container, one has 3 container, one has 2 container. Normally, you can have up to 110 bot per working node. And if you are going to host this in the cloud, this number might be less than that. Now let's talk about the components inside the master node or control plane node or API server. We call it sometimes API server or master node or control node, both are the same. We need to check what is the component inside, and in the working node, what is also the component. You will find that we have 4 main components in the master node and 3 main components in the working node or the worker node. And it looks like each component is responsible for something. So in my master node, I have API server, I have a scheduler, I have controller manager, and I have etcd, a database. And in the working nodes, I have the kubelet, I have kube proxy, and I have my pods and my Docker application. So let's try to understand more about these components. For master node, we said we have 4 components. The API server, this is normally responsible for internal and external communication between all components, and it is using REST API. In another meaning, if a working node would like to talk about to the master node about something, he will talk to this API server. This is the front desk for the master node. Master node will collect information, data, and configuration file about himself and about the worker nodes, about everything. He will store it in a database. We call it etcd. So this is the second component. We have also controller manager. Controller manager will be responsible to create and join cluster, create bots, doing authentication between all the components, handling any node failures and replication when needed. Remember when I said you can have the same container in one working node and in another working node. If one goes down, the other one should come up. Controller manager will help us also in that. When you talk to the master node and try to create a microservice application, and this microservice application will be made of 5 containers, and you would like to have the 5 containers and 5 pods. Now, who is responsible to talk to the working node and telling them you should have these pods created? And it is the scheduler, and scheduler normally will be responsible also to make sure that the worker is ready to hold the pods and it have enough resources for that. Now, API server, etcd, controller manager, these 4 is actually 4 containers inside the master node. You remember when I said K8 is working as a microservice application? So that's why, by the way, we need Docker installed in master node, because these 4 components will be running in containers. Now, maybe you'll ask yourself, okay, how I will talk to master node to create my application and this stuff, there is a command line, we call it kubectl. This is the one that you are going to use, and you can install and set up kubectl in your machine, in your laptop, and communicate with the master node and start creating whatever you want. So this is one of the methods to communicate with master node, by the way, as an administrator or as a we have also, by the way, a graphical user interface. I will explain it in the end how to install. But there is a graphical user interface also with K8s. So we finish with master node. What is the component inside the working node? In the working node, we have the kubelet. What is a kubelet? You remember we go through different tools, and some tools we said you need to have agents to be able to communicate with the devices. Like you need to have a Puppet agent when you are using Puppet. That's why Ansible is good. It's agentless. You remember when we talk about Prometheus? Prometheus exporter is acting as an agent. The beats in ELK is agents. Kubelet is Kubernetes agent. It is the one responsible to start talking and communicating with our master node, communicating with the API server. So if this is a working node, it should have a K8 agent, and the K8 agent is called kubelet. The second component in working node is called kube proxy. Kube proxy is used for communication to your application container from inside and outside the K8 cluster. Simply, kube proxy is going to make the user, through the internet or whatever, can use the application. This is one of its own job. Finally, the last component in the working node is the Docker itself, or the container software that creating containers for you. It is the container runtime interface, we call it. CRI is the software that's going to be used for running the container inside the working node. And in our example, it is Docker for sure. So these are the main components in the master node and the working node. And now we can say this picture from your official material is now making sense. We have another components, namespaces, deployment services, DNS server capability, the graphical user interface. So the basic workflow of deploying application in K8's cluster is containerize the application component, make the images available in image registry for these containers that you would like to create. K8s will need to have access to the registry. So in another meaning, if you are using it with GitLab, you need to access the GitLab to get the images. Who is going to get the images? The machines that are going to have the pods or the container inside it, which is in this case working node. So working node is the one that's going to pull the images and create the containers for you. When we create the containers, there's sometimes descriptor that can be passed in the request to the master API server, to the master node and the API server. It's explaining some important information, like our application is made of 5 containers, but container number 5, I would like to have it, to have a 3 version of it, or a 3 replica of it. You can do that. Scheduler will start now seeing all this information and start controlling which working node going to create these container, these pods, and which one is going to create these pods, and so on. Here in this example, we are seeing this deployment descriptor that I talk about it. It is a YAML file that you are going to use to write what you would like to have inside your cluster. You would like to have three applications, three containers. These three containers, container one, container two, container three, is making your application, and you decide to have one instance of this container, four copies of this container. It's same component, same stuff. It is a logging it is a container providing a log functionality for our application, but I need four copies of it. This is what we mean by four instances here. Here I have three instances. Then your API server will receive the request, will tell the scheduler to start checking what we should do. Your working nodes, you have here three working nodes. This is a working node, by the way. This is a working node. This is a working node. These working nodes now will start installing these containers. Any container, as we know from before, need an image, right? So each working node might go to the image registry to download the image so he can create the container that you are asking for. But notice that this working node here is creating only one container from one copy of the container from this second here and another one from here, but the first one, no. Who decide that? This is thanks for the scheduler. Scheduler in the master node will decide which working node will do what. Now, let's try to fix this thing in the second subsection related to K8 storage. As I show you before that when we go to the official material in the K8 storage board, they start showing you few lines. It looks like YAML file content, but what is this? How to do it? What it means? This is what we'll try to explain here. Your bods is normally described in bod manifest. It is a text file and normally can be written in JSON or XML, but in JSON or YAML, but we normally prefer YAML. Your Kubernetes API server, who's the API server, your master node, will accept and process this bod manifests, and he will store the manifest in his database etcd. The scheduler will start reading the manifest and see how many bods we need to create, what is the specification of these bods, and he will start telling the working node to do it. Actually, bod manifest is this deployment descriptor, if I would like to call it. Now, this is not the only way to create bod, by the way. So if you ask me, this is the only way to create bods using bod manifest, then using kubectl command. No, you can use kubectl directly to create your bot. Notice here that this one is kubectl run. Then I'm running a bot called Quart. Then I'm mentioning what is the container image that it is going to use, and that's it. And this is my bod, and I'm giving the bod a name, and inside, so I'm creating one bod. This bod will have a name. It's called Quart, and inside it I have a container made from this image. That's it. You can do it like this, and you can do it with bod manifest. In general, most of the time in the 3 section, we will talk about how to do it from bod manifest. In bod manifest, we have the concept of key fields and attributes and sections in this YAML file. There is a section for metadata. There is a section, this will describe the bods and its labels. Specification or spec section, this is for describing, for example, volume and list of containers that will run in a bod. Now, what you need to remember that in this YAML file that we are creating, this bod manifest, you are creating different K8 objects. Okay, so I have the concept of objects here, K8 objects. And what is K objects? Give me example. Bod itself, the bod itself is a key is a K8 object. So notice here, this file or this quart bod YAML, which is a manifest to create a bod, it is doing, by the way, the same thing that this command is doing for us. Okay, maybe with some extra details here. Notice here that I'm saying ABI version 1. There is a version for your ABI that you are using. You'll type V1. Then notice the word kind here. Kind is the type of the object. You are defining what is the type of the object. I said this YAML file will have different objects. One object type is going to be bod. That's mean anything will coming after that and under the kind bod is related to creating a container. Remember that we said your bot could have one container or more. Here I have one container. The metadata related to this object, it is just the name of the of my bot, corp. So I'm creating a bot and I'm giving it a name here. Then the specification. What is the containers inside this bot? I have one container, because I didn't mention that I would need to create more containers. The image, this is the image that I will create container from it. What is the name of my container, and maybe some information about the port number that I'm going to use for this container and so on. If you create this file, which is, let me clear this. Now, if you create this file with this content, now you would like to run it so you can create this bot, you will type kubectl apply -f for the file. That's mean you are going to mention a file after that. And here is the name of the bot manifest. This command will run this or execute the content of this file. This is a way, and there's another way is using kubectl run and go directly to create the things. But anyway, why we said we will use this way or this method, because in bot manifest you can write a lot of things. You can mention a lot of information. First of all, you can in one bot manifest I can mention how many bots I would like to create. Let's say 3 bots, so I will have 3 objects. Then I can create another object representing the networking capability between them. You can do a lot of things. Now, we can start talking about the K8 storage that they talk about it in the second section, in our chapter section 16, section 2, or subsection 2. When I said they will start talking about K8 storage without explaining, that's why we need to understand these 3 slides or 4 slides. Okay. Can have idea about what's going on here. Now we will talk about K8 storage. What is K8 storage? Simply, same like container. Container needs storage for persistent data. You have a persistent data, and you need to store it somewhere, so the container, when it is running, can save some data, pull some data from this storage space, and we call it volumes, and we have mind-bound point in Docker. Here in K8 we have 2 options: volumes or persistent volumes. So you have 2 options here to provide storage or persistent data storage for your what? Bots. We are calling containers now bots. Right? Here I'm creating in my manifest a K8 object from the type bot. I'm naming my bot example bot. Then I'm giving specification. Again, you see that metadata is just labeling or giving a name for our object. Specification here, and inside the specification now, as I will start talking about containers. I'm creating a container with this name. This is the name of the container. Then I'm mentioning that this container will use a volume for persistent state, for his persistent data. Sorry. Here I'm mentioning that I will have a volume object, and this volume object will be named example volume. And notice I'm telling him where is the path for in the working node hard disk where I'm going to save, where I'm going to have a directory to use it as a folder for my persistent data. And notice also that there is something very important: the volume type, host file. Here it is. I'm telling him, hey, for the volumes, this volume is host path. Now, okay, so I understand the concept of volumes. We didn't talk yet about persistent volume. I'm talking about volumes, and it looks like the volume itself, it has its own types. Yeah, we have a lot of types, as you can see. All these are types of volumes that you can use any one of them to give it to your bots. By the way, if the bot turn it on and it is not deleted, he will keep the bot will keep using this for sure, this volume. So we are saying the volume exists as long as the bot exists. So if I lose the bot, if I delete the bot, that means the volume does not exist anymore. Also, there is something important. The bot itself is made of one container or more, right? Any containers and these bots can use this directory or folder that to save the data or get data from it. So it is available for all containers that's running inside this bot. Here I create a bot called example bot. So this example bot has what? Has one container here. If I create one container or more, all of them will still use this volume. Now, the question that they try to ask in your official material is you don't have to pick just one option. It's not like this option is better than that option and so on. Each bot can have its own storage type based on the bot itself, based on the container inside the bot itself, based on the application actually. When I say the container itself, it is based on the application that the container is representing. Also based in the environment where your working node and your bots are exist. So you have two options. Sorry for that. Two options to choose your volume type: the environment or the best suited for your application. For environment, I will need to think, where is my K8 is hosted? Where is my master node? Where is this cluster is hosted? On premise or in AWS? If it is in AWS, for sure, when it comes to my option, I can use, for example, AWS Elastic Block Store. This is the preferred one, preferred volume type that you should use. If I'm talking about application, it depends. If the data only need to be available for the bot at runtime and does not need to exist when the bot is deleted, you can use mtdir, you can use CH if you require a high availability for your folder. If I use this type, it will provide me with like two directory. One is acting like a mirror for the other one. So this is volume. There is another type of K8 storage that we can use. It's called persistent volume. Now, if volumes will provide for the bot a folder to or a storage location to store the persistent data, persistent volume is made for the cluster. So whatever this pod and this host, whatever this pod and this host, there is maybe a third host or something that's providing a location for them to save their own data. So I'm providing a storage solution based in the cluster itself. So it is bare cluster, not bare node. Volumes is for bare pod. Persistent volumes are going to be bare cluster. If I would like to give my pod access to a persistent volume, which is provided for all the cluster, in this case, I need to mention in my pod manifest this term here, persistent volume claim. I need to claim or request the access to this persistent volume in my pod manifest itself. For sure, multiple pods can mount to the same persistent volume in this case. So you can see here, I'm creating object, but this time this object, for sure, this is, you need to remember something, that this part of our manifest, this is a part of manifest file. So above this, maybe you will see the creation of pods, objects, and these stuff. But a part of it, there is another object here, because you remember when I said the pod manifest is made of different objects. Here I have an object called persistent volume claim, and I'm saying that the name of it is my claim, and now I need to use it later. I can mention it later now with another bot, and I say I would like to use this my claim, and this my claim is giving me access to the persistent volume with specific storage, 8 gig or something. When it comes to networking, your pods in the node can communicate with all pods within the cluster without any NAT capability. Everything is fine. The pods itself inside the cluster, they can talk to each other from one working node to another. We have something called container networking interface to implement the network model. We call it CNI. It is API for connecting containers to the network. And we have many CNIs. We have Fluenel, WaveNet, and we have ACI, application-centric infrastructure. Frankly speaking, you can fully integrate Kubernetes to your ACI solution. And you can use the EPIC, the APIC, to view the Kubernetes servers that exist in your ACI solution. This integration is happening. They didn't explain it that much here, but I will tell you, go to this session in Cisco Live On Demand sessions. It's for free. Just use your Cisco account and log into the Cisco Live website. Search for 2505 BRK ACI. They talk about how Kubernetes will going to integrate it with ACI solution. And they will give you a lot of things. You can, frankly speaking, you can even make your Kubernetes users access your bridge domains, your subnets inside the ACI, fully configuration. And by the way, we have a good lab for that in DevNet Sandbox. It is called ACI and Kubernetes. But anyway, they didn't explain a lot of, they just mention it here in the CNI in your official material. Anyway, we have some issues with the networking, with pod networking. First, bots can be created and destroyed dynamically, and based in the intent of the business and all these stuff. Some bots in the back end can provide functionality to the front ends, and they need to communicate. How the bots will know the IP addresses of the other bots? Remember that I said the bots will have IP addresses and they can communicate with each other internally inside the cluster. How are bots accepted to know the IP address of other bots? How can application be accessed in the bot if the IP address change? Another important thing, what if I change the IP address for the bot? In this case, a part of, if this bot is representing one container, which is common, in this case, this part of functionality in my microservice application might not be available or not working. How to solve this? We can solve this with a concept, we call it service. Service will solve the bot networking problem. Service is another K8 object, by the way, that you can create inside your manifest file. There is something called selector will be used to specify the application that's going to use this service. Service normally will make use of the kube proxy. Remember this kube proxy that exists in the working node? Services will depend on it, so it can send requests to one of the pod that service application. Notice here we are creating a new type of K8 object. It's called service. It has this name. Here in selector, this part, I am mentioning which pod name that's going to use this service. So here I'm mentioning my pod. This is the pod name, and this is the service name. Then using the selector, I'm tying my pods to this service name so they can use this service name. Then after that, I will go through some specification like port number, target port. Normally, port here will be the port that made accessible by the service. Target port is the port in the pod itself. They don't have to match, by the way. Just put it here in the example. Now, another important thing that I can add it here is the type of service that I'm using. This service that we are talking about here, it's a little bit similar to network driver that we have it in Docker when we talk about Docker. So we have here 4 different type of services. Cluster IB, this is the default. If you didn't mention, here in this example, I didn't mention any service type, right? I just give my service a name. Now, what is the type here? By default, if you didn't even mention it, the service type is the default. This service type is the default, cluster IB. That's mean I can access the pod. Let's say I have a pod here, and this is a working node, and this is represented in a cluster. And we have a lot of other working nodes, and the cluster itself will have IP address, and I will access this pod using the IP address for the cluster itself. This is the cluster IP. The node port, no, I will access the pod by using IP address representing this working node with a port number for sure, which is in this case the port I mentioned it here. This is normally the two common ways to communicate with our pods, using cluster IB, which is the default, or using node port, communicating bare nodes, not bare cluster. There is another one is mapping the service to a DNS. So I'm just using like a DNS CNAME record, not selector. We call it external name. Also, we have load balancer. This is normally when you expose the service using cloud service provider. The cloud provider will providing you load balancer. Then we need to talk about K8 security. What is the security features that we can have it in this K8 environment, in the master node, in the working node, in the cluster itself, and in the pods and all these things. Here we are saying that we focus in 4 cloud native security. The 4C of cloud native security. The 4C is simply means the 4 area that you should focus to secure. You should focus to secure the cloud. If you K8 is representing in a cloud, you should focus in K8 cluster security. You should focus in the containers, the pod itself, the container itself inside the pod. You should secure it. Then finally, you should secure the code inside the container. Remember the code inside the container. The container is inside the pod, and the pod inside the cluster, and the cluster inside the cloud. So you need to make sure that all these 4 areas are secure. If we start with the cloud infrastructure in which K8 is running, we need to make sure it is secure. The access to the K8 master in your cloud should not be allowed publicly. Access control list should be used. Um, the K8's access to the cloud provider API should be limited. I don't want to also that my cloud provider have access to my master more than what he need to do. Access to the database itself, the etcd inside the master should be limited to the masters only and the user of the masters only. And if you can use encryption for the etcd will be good. The cluster itself, we need to secure a lot of components inside our K8 cluster. This is something we will see in the next slide. So let's jump to the container. The container, you need to secure container that run within the boots. So what you will do, you remember that file that I was talking about this side from OWASP from OWASP side that giving you 12 guidelines or to follow or rules to follow when you would like to secure your containers. You need to do that. Run the container with no root users by default. Don't use any services that you don't need. All these things that they put it, plus adding some encryption and don't take the images from a trusted location, upload it to trusted location, and all these things. Anything related to container security will be applied here. Try to use with the from tag. Try to use the version, not the latest. It's more preferred. The code itself inside the container should be secure. We should put it in CI/CD pipeline to make sure that we and do some tests, especially OWASP top 10 test, to make sure that my code is not vulnerable to SQL injection, XSS, CSRF, all these type of attack. We talked about it before, and all these things. Also, you try to use TLS communication everywhere. Now, if we talk about cloud container code, what about the cluster? I said that cluster, you need to secure the component within the cluster, within the K8 cluster. How to do that? This is the that we try to talk about it in the next few slides. We have few strategies that you can use it for cluster security. You can use role-based access control authorization, network policies, resource quota, quality of service classes, and how to deal with secrets. So these 5 is going to providing you a sort of strategies to your cluster security strategy. First, the role-based authorization. Now, who's talking to my API server? Who's talking to my master node? Normally, maybe another node, maybe your kubectl in the client. So can we have user capability? K8 is not providing this directly, but you can make, since we are using HTTPS here, that's mean we are using TLS, that's mean we are using certificates, so users can be represented and prove themselves from their own certificates. So certificate authority should be exist, and I can authenticate, because you know that in public key infrastructure, the certificate will provide us authentication also, so I can use it here. Then I can start saying, let's take the user and put them in a groups and roles. I can do that. Then finally, I can use some network policy to do some admission control, what they can do and what they cannot do. So if I said who can perform which action in which resources, the user is going to be a subject in the certificate. The action, this is something I can mention it in my pod manifest or in my deployment descriptor here. I can mention some verbs here, like he can create, he can update, he can delete, he can watch, he can whatever. And he can do these verbs or these things, he can do it where? He can do it in these resources, deployments, pods, services. Maybe we understand pods, we understand services. In a minute, you will understand also what is the deployment. But anyway, this is how it is. So role-based access control authorization will provide this for us. And there's two options for roles. We have the role and we have the cluster role. Now, it is similar to the same concept when we was talking about volume for a specific pod or volume for a for all the cluster. We have the same concept here. Role for specific user or a group, or namespace. Maybe the word namespace is not clear here, but we will talk about it in the second chapter, in the second section today. But anyway, simply it means a user in the end or a group. Or you can create a role for within the cluster itself, for the cluster itself. So if you have a role and you create it, then what you need to do is role binding. It is binding the user to this role. If I'm using cluster role, I will do the same here, cluster role binding to the cluster role. Notice in this example, I create a role, I create an object from the type role, K8 object, sorry, from the type role. Then I create a name for this role. And this role is ACGRBC, whatever the name is. Okay. And forget the namespace. Namespace is something we'll talk about it later, but you can do it without namespace. Now, what is the rules? The rules that I can deal with resources. Okay, good. Resources like pods, for example. Yeah, here it is. Okay, what is the verbs that I can do? I say that you can get, create, watch. Here I can get or list the bots or watch the bots. This is the things or the capability that I can do against the bots. So this object is role. What I need to do now is creating another K8 object called role binding and mention some user inside it. Then take it, then mention that this role binding will use this role GRBC. So let me delete again. So you can see here in this object role binding, I'm saying that this role binding will have a role reference. First of all, I have subject, by the way. I have users here. Here is the user and his name. I got it from the certificates. The role reference, the reference for this role is a role name ACGRBC. So what is written in this role name ACGRBAC will be applied to this user with this email. And what is in this role? Here it is. So this will be applied to this guy. Network policies, another important security thing that we can do it in the cluster. To make it easy for you, it is simply like access control list in routers or switches. You know, in access control list, but with one condition. It is like access control list with only permit lines. You remember in access control list, you can permit this network, you can permit this host, and if you stopped here, there is a hidden line saying deny all. So it is like creating a whitelist. So network policies here is a whitelist actually. That's why I'm saying it is like a access control list with permits lines, because there is a deny only, deny all in there will be applied. So it is a policy that acting as a allow list, and anything outside this policy will not be there. So it is like a whitelist. All traffic that is not specified in this applied policies will be blocked. It is normally specify how bots or a group of bots can communicate with each other and other network entity. So this is, if I will say network policy is similar to access control list. In access control list, we are talking about networks host. Here I'm talking about bots and a group of bots and how they will communicate with each other. This is the benefit of network policies. And you can also, again, in our YAML file, create an object from the type network policy, and I can start in the specification, define exactly what I would like to do, what is the IP addresses that going to block and ports and all these stuff that going to, sorry, not to block, to access permit. Another security feature that you can have in the cluster, it is not security feature, but it will serve you in the security perspective, resource quota. Prevent team from consuming more than what more than their share of resources. Can prevent a malicious user from taking down production by consuming a lot of resources. DOS attack. It is simply telling you that if you are going to create 5 bots, you cannot go to one bot and say that I will use a volume with persistent volume with 5 tera size. You cannot create 20 or 200 bots every 1 minute. All these things could happen, and to limit it, we can limit the resources itself. Also, it is useful when we are doing something in the test environment. For sure, we can limit the resources than the production. Quality of service classes. You can give your bots some quality of service capability. There's 3 classes, and you cannot define any extra one. It is already created for you. All what you need to do is mention which class you prefer that your bot is going to use. We have guaranteed quality of service class. That's mean every container in the bot should have a memory limit and memory request at the same time, CPU limit. Restable quality of service class here, that's mean the characteristics of the bot here. At least one container has a memory or CPU request inside this bot. Anything that does not meet the first class can be here. Best effort, we are not using quality of service like this. That's it. None of the container will have a memory or CPU limit request. Secrets. Secrets will allow you to store and manage a small amount of sensitive data, such as password tokens, API tokens, API keys. Can be used as an environmental variable when you are creating the bot. You can mention that inside the YAML file. Anyway, secret cannot be used to store large amount of data. Remember that you are limited to 1 meg, 1 meg, megabyte, 1 megabyte. There are also some limited number of secrets that can be used. Sometimes it will be good also to store some data, even if it is not a secure data. It's not secrets, but maybe some data that you would like to store it somewhere in a folder, and save some information, some data related to a path for a specific thing or something like that inside your bot. You can use something called config map. A config map will be used to store non-confidential data in key value pairs. Then bot can consume this config map inside a specific volume. Finally, for this section 16, they talk about Kubernetes API overview. They will start talking here about manifests. As you can see, it is a little bit too late to talk now about manifests. It should be like what we did. We talk about it from the beginning. Anyway, manifest is going to use to specify the desired state of an object. Yeah, we saw that. We saw different type of object, different type of kind in another meaning. And we was mentioning kind bot, kind volume or whatever, and we was mentioning the desired state, what we're looking for. As we said, it can be in JSON or in YAML format. By the way, you can have more than more than manifest stored in the same YAML file. In another meaning, you can have more than a block of objects or data about objects. You can have it inside your YAML file. In another meaning, YAML file has the capability to have a set of blocks, and all what you need to separate these blocks from each other is putting 3 hyphen, which is a start of YAML file. And it's like multiple YAML file in one file. What's that? So here in this file here, in this deployment descriptor, we are talking about, we are creating a service. By the way, always in your file, you need to start with service first. You don't start by saying, I would like to create this pod or something like that. You start with service first. Here it looks like we are starting with the service. I'm giving it a name. What is the type of the service? Cluster IB or node IB? No, I'm doing it load balancer here. And I'm applying it to which container, which application, or which pod, sorry, which pod name. It is nginx. Then after that, I have a deployment object, and in this deployment object, I'm trying to create something. Now, wait a minute. What is deployment? We talk about pods, but what is deployment? Deployment is good when it comes to create a replica of your pods. So imagine here that I would like to, here I'm saying kind deployment, then I'm saying in the specification, in the replica 3, create 3 pods for me. I'm imagining that each pod will have 1 container. So create 3 copies. You remember when we said 3 copies? And I remember we saw it before long back when we start here, for example, when I said create 4 instances. If this container here or this this pod here is nginx, and I'm writing this in deployment descriptor, this 4 is going to be seen. Going to be seen here instead of 3, see 4, and so on. Anyway, as I said, service is really important, and here they are explaining the same thing that we talk about it. Now, mandatory fields. Since we are talking about the file, the YAML file or our deployment descriptions, descriptor, it is very important to remember a few things. First, we saw that kind here, we saw kind, then the type of the KH object. We saw also API version. We can see metadata. We can see also name. These are called mandatory fields. API version will contain the API version number and sometimes API location. In general, we have, when you deal with the APIs, there is version. In general, you will have V1, but maybe after a few years, for this product, you will find it you can find it V0 now, I will find it V1, then V2, and so on. You need to mention that. In general, nowadays, it's V1, as I know. The kind is the type of your API, your K8 object, and we say that we can have kind deployment, kind pod, kind service. But anyway, if you would like to create an object for service to mention something, maybe you would like to be more specific about your cluster IB, or you would like to be more specific about, or you would like to create a new service type, like use node IB or use load balancer. In this case, service should always be the first thing that I will see in the file in the beginning. Then we have metadata, just a metadata, and name, just a name, and namespace is something we'll talk about it in the end. Don't worry about that. It is capability to divide your cluster to virtual clusters. You remember when you work with ASA and you can create context version of the ASA to virtual ASA inside the physical books? We can have that in the cluster by having the namespace. More about that today after the break. So I guess we deserve now a break before we go to continue with this cube CTL. Now it is time to say, okay, wait a minute. Whatever you have the file, or you would not use it, you was using this kubectl command. So let's do it. It's like Docker command in the Docker. So let's talk about it. We'll do that after the lunch break. I don't know. Tell me if you have any questions right now. So,
yes, sir. Sorry.
yeah.
On the chat, can you just paste the important labs we need to do? Then tomorrow and this evening, I'll try and finish all those labs,
Yes.
please. Thank you.
Here.
They're all important, Darren. All of them.
All of them are important. Yes, but just in case if
Just no time.
yeah, just in case if tomorrow you have like 4 hours remaining and you didn't finish everything, check this list and try to
Yeah.
pick the most important one. But they all
Okay,
important
cool.
for sure. Yeah, they all give you the right experience for DevOps topics and tools.
Thank you.
So here we have the kubectl, the tool that we can access the Kubernetes or Kubernetes or K8 cluster. We can use it to retrieve data from the cluster. I can use it to know how many pods I have, which one is running, which one stopped. I can know how many deployments I have. I can also use it to create objects in the cluster. As you can see here, for instance, I can create some resources from YAML file. This one that we use it to as an example, and we said we can use nginx to create three pods from the same for the same container. You can just type kubectl create and mention the file. Also, we have the kubectl apply and the same file. So what is the difference between create and apply? Both are going to do the same thing. There's a difference between create and apply. The difference is simple. Create is, let me see, I have it somewhere here. Somewhere here. And other slide, there is the difference between both. But in general, create will act similar to a declarative mode. It is similar to Terraform. You are going to define in this YAML file your desired state, and that's it. And apply, it will apply everything by commands, one by one. This is that different. But in the end, it's creating resources for you. Now, installation of K8s, they didn't talk about it. They are saying it's simple. It's not a simple exercise. But we are mentioning here, I don't remember if they mention it in your official curriculum or not. Kubernetes website is providing you few tools that you can use, any one of them, to create an educational environment for running K8's cluster. One of them is called Minikube tool. It is going to run a cluster in a single node, and it can help you to practice with it. There is some commands extra that not related to kubectl. You need to run it first, like Minikube start. If I have Minikube installed in my machine, in this case, I need to type Minikube start, and it will create this single node Kubernetes cluster in your personal computer. if you go to this website here, you will find that they are showing you few tools that you can use any one of them to practice with K8s. And let me share it with you. It's a chat box also. And as you can see, we have here Minikube, we have Cube ADM. These two, by the way, is similar to each other. They are providing you this K8's educational capabilities and environment. So Cube ADM is doing the same thing also. This maybe will lead me to say also, if you would like to quickly start with practicing K8s in Katakuda that we saw it before with different tools, you can see that we have different scenarios here. Deploying, for example, containers using kubectl. I just start the scenario, and sometimes it will ask you to sign up with LinkedIn or Google or something. But after that, again, let me go to introduction, kubectl, now start the scenario. I hope now it makes me log in. Sometimes it's taking time for login. But you can use it. No, not all labs, by the way, will require using this. Let me try another one. Yeah, like this one, it's going to be working fine. Normally, it takes time when you deal with these websites. So, to providing you a Q8's environment, in the background, they need to prepare a machine for you, virtual machine, so you can use it. But once it is finished, you will find this steps is active, and you can practice it similar to what we did before. I remember I showed you with Terraform, as I remember. There is another website also. It is similar to Docker playing. Same one, but playing with the Kubernetes. You can use your Docker account to start with it. Now, it is made by Docker guys, and what I need you to remember about this thing here, K8, playing with the labs to play with K8s. Let me share the site again with you. What you need to remember here, you can create an instance. Instance here, it should be one of the one node. So I'm creating here maybe one node. You can create multiple nodes in your cluster. It is up to you. It is using Minikube, as I remember. And you can have environment to practice with K8. Sometimes it will not work with you, depending in. That's mean they have some load in the website. So just wait a few hours. It came back. It will be working fine with you, like what we have here. But you need to know what to do in this lab, right? What I will do now, what is the command to create stuff? If you are asking yourself this, the answer can be found in this website. No, not this website, but this is another website that's showing you some. Normally, this is not the one that I like to show it to you. Would like to show you this one here. Yes. Let me share it with you. This website I really like. It is trying to explain to you Kubernetes in a very good way, and it is providing you like a workbooks for doing or practicing with K8s. You start one by one, by the way. If you go from the first of the page to the end, you are starting with the basics. So the first one is Introductory Slides. Here you will find slides that they are trying to explain to you things. By the way, he's using here a very good way. you have a carrier ship across the sea with these containers, and this ship is your working node, and you have a control ship uh, walking beside it, and this is your master node. And for example, the cube scheduler. You remember when I said the scheduler can know which working node is available to put some bots on it. It is like the ship cranes. He tried to explain to you the same concept that we talk about it in their own ways. I like it. But also here, for example, deep dive into Kubernetes architecture. Here they are talking about what is K8 kubectl, what is master node. Again, a lot of information. Now here, preparing 5 nodes Kubernetes cluster on Play with Kubernetes platform. He's telling you go to this website and follow what he's going to say here. He's showing you need to go to Play with K8s, and now you can follow the steps that he's telling you to do to write, and the commands, and you will create five nodes cluster. In the end, you will have here in the left 5 nodes if you follow that. Very powerful website for anyone who would like to practice K8s, frankly speaking. Anyway, let's return back to our talk. kubectl is just a command line client. You can install it in your laptop, in your local machine, and use it to communicate with the master node, with the API server, actually. When the K8 scheduler decide which working node will host his component, why this shown to me, right? There is a deployment controller will contiguously monitor the state of the components. What does this mean? Simply, I said that you can create the pod one by one, or you can create what we call a deployment. When you create deployment, that's mean you are looking for high availability and failover for your pods. And there is a deployment, sorry, where is it? Yeah. Deployment controller will be running in the background, monitoring the pods in the different working nodes, and make sure that it is the number of replica that I decide to create is exist in my servers. And also, if I decide to have one pod acting as a active standby for another pod, there is something called replica set will be also help me in that, and once this pod goes down, it will make this guy turn it up. So you have the deployment controller, and you have also the replica set there. Here is an example for creating a pod name called devnet example. Then I have this image to run it. I'm using this board for it, and here is I'm using a flag for replica. This flag replica 3 is similar to the one that we saw it in the YAML file. Both are doing the same thing. kubectl is good, as we said. It can show you how many pods you have. You can type kubectl get pods. You can find how many replica set exist, and what is the pod that, and how many pods it is monitoring. kubectl get rs. You can also mention the load balancer, the type. You can find how many service you have. It's similar to Docker network ls. It is doing something similar here. kubectl get service. It will tell me that I have two type of services, load balancer and cluster IB with this name, and the IP addresses for them. You remember when we say Docker container inspect, then the name of the container to see more information about the container. It is like X-ray for the container. What is the images? What's the IP addresses it is used, and all these things. You can have the same thing here. We call it describe. So describe is similar to inspect in Docker commands. kubectl describe pod and the name of the pod and it will give you information, the pod name, the IP address, the labels, everything. Here, deployments. I was talking about deployment, that you can create more than. Here, for example, you can create a replica of your containers. Anyway, deployment need a name. It is in the end K8 object. All this we talk about it. Okay. You can update existing container image. This is something K8 can provide for us with this command, kubectl set image. In another meaning, sometimes you will have pods, and the pods will have a container, and this container is using, for example, this image, and this image now updated. I need to update the image that make these containers running, and you can do that also.